Okay, so in this problem, we have an unknown charge placed at the origin of the axis shown below. You measure the electric field strength to be 1,481 newtons per coulomb at point A. What will the field strength and direction be at point B? Okay, so first thing you're going to want to note here is that because the field at A is pointed towards the origin, we know it's going to be a negative charge because the field will always be pointed towards the negative charge away from the positive charge. So immediately we know that the direction is going to have to be down because at point B, it's going to have to be directed downwards towards that negative charge. Now, in order to find the field at point B, what we're first going to have to do is find the actual charge of the particle over here, because I don't think they actually tell us. They only tell us what the field is at point A. So let's first write down what we know. We know that k is 8.99 times 10 to the 9. That's just a fundamental constant. Should be in your textbook. The distance to A, which is we're just going to call R1, we're going to have to use the Pythagorean theorem here. So it's going to be the square root of the x distance, which looks to be about negative 1.5 meters squared. So the negative just ends up going away because this negative squared just becomes positive. And then the y distance looks to be about 1.4 squared. So this should give us the value of R1. Now, knowing that, what we can do is actually use the equation E equals KQ1 over R squared to figure out what the actual charge of the molecule is, because we know that in this case we're going to use R1. So let me just write that down, R1. So we know that this is actually equal to 1481 because that's what's written up here. So rearranging this equation, all we need to do is just put R1 as our distance value here. We just rearrange the equation, multiply R1 squared on both sides and divide by K. We can get Q1 equal to 6.93 times 10 to the negative 7 coulombs. Now, knowing this piece of information, we can then go to point B and and then use the electric field equation again. In this case, we're just going to use R2. So what's R2? Again, we have to use, actually in this case, we don't have to use Pythagorean theorem. If B was like over here, then we would have to use it. But in this case, it's just vertically upwards. So that looks to be about 0.7. That looks about right, 0.7 meters. You don't have to convert to SI units in this case. So if we input that, we get a final E2 value of 12,724. So let's input that information. It's 12,724, and the direction is downwards. And great, your electric field value and direction are good. That's how you do this problem.